Hello everyone, my name is Joshua and I'm going to teach you how to do this almost increasing sequence question. And the question is, and you can do this in Codesignal. It's in the arcade section and you can find it as almost increasing sequence. Anyways, back to the question. Now, you're given a sequence of integers. Basically, you want to make sure that they're strictly increasing. So in this case, if they're tied, like it would just say it's this 1, 1, 2, 3. This is not strictly increasing because they equal each other. You have to be at least a difference of +1 from each other. Now, the question is saying that you have to return true or false, whether that's true. And you want to be able to, oh wow, that was so squeaky. And, okay, I'm sorry about that. Now, you want to make sure that if it is not strictly increasing like this, you can remove at least one node to make sure that it is strictly increasing or not. So in this case, this is still following the rules of strictly increasing because you could remove this node 1 to ensure that it could be strictly increasing. So in that case, some base conditions to consider. I mean, here's some more examples. 1, 3, 2, that's true because you can move the 3. 1, 3, 2, 1 is false because it goes down to 2 and then it goes down to 1. That's a problemo, and that's why it's false. Now, some things to consider. Okay, a sequence length has to be 2 or more. So I'll just say that if let's just have that. Usually you want to, explain to the, maybe I should just do the same thing. In your interviews, you want to explain your game plan. I'm thinking to iterate through each integer and check its neighbor if it's less than or greater than. If it's less than, when I say neighbor, I meant the right of that value in the position. Maybe we should do it step by step. Iterate through sequence. And for each val, check its right neighbor. And if neighbor is less, now here's what you want to do. You want to make two assumptions. One, you could skip your current neighbor and go right across. Or you could skip, this is a bad example, such a tiny number. Shoot, let me see if I could see a better one. Here, 1, 1, 1, 1, 1, 1, 1, 2, 1. All right, so make this a 3 and make it distinguishable. So what you say, you see a 1 here, I could skip this across and check if that one is strictly increasing, or I could skip the current number I'm on and go back in time to the previous node and see if that is strictly increasing with the other one. And if one of them fails, if one of them, and that should determine, if both of them are, if both of them still don't correspond correctly, that means in no case scenario that if you do remove a node, then it will no longer be strictly increasing. So here's an easier way to explain it. If neighbor is less, check across neighbor, or skip, or check neighbor with previous current value. Oh, that was a bad way to put it. Previous value. There, yada. Am I recording this? Oh boy, I was recording this whole time, guys. When you get back to the coding stuff, you're out of the game. You got to keep this as good practice every day, guys. Am I right? All right, check across the neighbor, check neighbor value. Okay. And if both are false, return false. That means you're definitely not strictly increasing. Otherwise, you want to create a counter. So you want to create a counter for errors like that. And if you have more than more than one error, then return false also. So there are two cases, skipped across neighbors and script itself, still false, then return false. More than one errors of the strictly increasing, return false again. Now to solve this one, now I want to create a size variable. Now if the size is, let's just say, equal to 2, then you can return true because regardless of whether it is true, whether it is increasing or decreasing, you can remove one node and it'll still always be true. Now, let's go ahead and check the next one. Now we want to iterate through the array. Now we don't want to go all the way across the array because we still need, we don't want to go get an out of bounds error. Now if the position plus 1 is less than sequence, if its neighbor is less than or equal to, that's a problem. Then we increment the counter, which I didn't create. Get in the game, Joshua, get in the game. And I want to check its neighbors. Is it possible? Oh, this could be a long boolean that I'm going to create. So I'm going to say I'm going to skip neighbor, and that's going to be, first we have to make sure that it doesn't go out of bounds, so it has to be less than size, and if it is not less than the size, then we can check if it's possible that it's less than or equal to the current node. And this is why I made my font huge so you guys can see this beautiful code that I'm writing, unless it fails, and that's no longer beautiful. Now I'm going to say skip back. So in this case, I'm going to put the chance that I can skip back, which means a position -1 is greater than and equal to 0. And let's see here. Then I could check the neighbor with the previous node that I came across, which is my previous last one right there. Now, if any of those is false, is true, let's see. Sorry about that, guys. I got a bind lapse there. That one returned false. Now, there might be a case that, 1, 2, 3, 2, 4, 5, 6, 7, 8, 4. So you can see there's two different occurrences. Two different occurrences where the values are decreasing. And they're far away that they sort of go out of range of this values right here of these this range, this window that I made. So I have to use the counter to make sure that it's still less than 2. Oh, or to make sure that if I have a long array and there's a bunch of issues that already occurred, I might as well just make this return true. But I could also say that if skip neighbor, skip back here, and I could also do a nice counter is greater than 2, then we definitely want to return false, greater than or equal to 2. And let's see if that works. Please be a smooth sailing. Hallelujah, guys. So I'm going to go over my code one more time. I'll give the time and space complexity. 1, I just need the size so I know how much of the array that I'm going to iterate. This counter is going to keep tabs on the number of times that it's not strictly increasing. And for the lowest scenario that it's size of 2, it's definitely going to return true because you can always remove one node and it'll strictly be increasing. And let's see here, if the sequence position, if its neighbor is less than the current value that you're on, then you want to increment that counter. But you would also check if its neighbors or its neighbor or its neighbor's neighbors still follow the rule that it's strictly increasing. And if not, you have to return false. And there you go, guys. That's how you solve this almost increasingly sequence. If you have any questions, please put in comments below. I'm sure there's a much better solution that's cleaner than this. Feel free to post it below, and I wish you guys a happy doodly day.